In this question, we're given two simultaneous equations, and we need to solve these algebraically. Now when we're given simultaneous equations with quadratics, which we can see in the first equation, x squared plus y squared equals 25, this means that we're looking for two pairs of values for x and y. So let's start by looking at the linear equation below. We have y minus 3x equals 13. Now in order to be able to substitute this into the equation above, we need to make y or x the subject of this equation. Now because y is already on its own, it's easy to make the y the subject, whereas if we had to make x the subject, we'd have to divide by 3. So we can see that y minus 3x equals 13. If we add 3x to both sides, we're left with y equals 13 plus 3x. Now we can use this value of y to substitute in to the equation above. So we know that x squared plus y squared equals 25, but we said that y is actually equal to 13 plus 3x. So we can say that x squared plus 13 plus 3x, all squared, equals 25. So now let's write this out as a double bracket. X squared plus 13 plus 3x multiplied by 13 plus 3x equals 25. And we can expand this using Moon method. Well, we have x squared at the beginning, and then when it comes to the double brackets, we can do 13 multiplied by 13, which is equal to 169, and then we have 13 multiplied by 3x, which is equal to 39x. Then we have 13 multiplied by 3x again, which is again 39x. And then finally, we have 3x multiplied by 3x, which is equal to 9x squared. So now we can solve this. We can simplify this further. X squared plus 9x squared is equal to 10x squared. And then 39x plus 39x is equal to 78x. And then we have 169 at the end. And then this is equal to 25, because x squared plus y squared equals 25. So now that we have this equation, we can bring 25 over to the other side in order to have a quadratic equal to 0 that we can factorize and solve. So we can say that 10x squared plus 78x plus 169 minus 25, which is equal to 144, equals 0. So now we can factorize this equation. So when we factorize 10x squared plus 78x plus 144 equals 0, we're left with 5x plus 24 multiplied by x plus 3 equals 0. And we can solve these separately. So we have 5x plus 24 equals 0. We can now say that 5x equals minus 24 when we take away 24 from both sides. So x is equal to minus 24 divided by 5. So now let's do the same with x plus 3. X plus 3 equals 0. When we take away 3 from both sides, we're left with x equals minus 3. So now let's go back, because we need to find the y value. So when x equals minus 24 over 5, we can say that y equals 13 plus 3x, which is what we looked at earlier. So we'll have y equals 13 plus 3 multiplied by minus 24 over 5, and so we'll get an answer of y equals minus 7 over 5. And then when x equals to minus 3, we can do the same. Y equals 13 plus 3 minus 3, therefore y equals 4. So now we've solved the equations, and we can write our answer out a little bit neater below. You can say that x equals minus 24 over 5, and y equals minus 7 over 5. And then x equals minus 3, and y equals 4. And so we've now solved the simultaneous equations x squared plus y squared equals 25, and y minus 3x equals 13. Now this question is worth 5 marks. The first mark, if for substitution of y minus 3x equals 13 into x squared plus y squared equals 25, which we did by finding y, making y the subject of the formula, and substituting this into x squared plus y squared equals 25. Now the second mark is for expanding the double brackets, where we had x squared plus 13 plus 3x all squared equals 25. We expanded this, and this is where we get that second mark. Now the third mark is for forming a quadratic ready for solving, which means we've made the right hand side equal to 0, which we've done over here when we have 10x squared plus 78x plus 144 equals 0. And now that fourth mark is for factorising and finding the two values of x. So we did 5x plus 24 multiplied by x plus 3 equals 0, and we found that x is equal to minus 24 over 5 and x is equal to minus 3. And now that fifth and final mark is for substituting the values of x back into the equation in order to find the two values for y. And so we're left with two pairs of values as mentioned earlier,